Welcome to the graduation projects orientation for the spring 2022 round. My name is Dr. Eman Azab, and in this short video I'm going to walk you through the projects that I'm offering for electronics major student for the graduation this spring round. For spring 2022 I'm going to focus on some themes. The project themes that I'm offering are in the scope of neuromorphic computing hardware, biomedical applications, IC design automation, and sensors application. I do mean by neuromorphic computing hardware is how to utilize electronic circuit ASIC design to implement the hardware required for neural network computation. And by IC design automation, I am interested in working in the field of automating the design process, whether on the circuit level or the layout level, using AI. And for the biomedical applications, the focus will be on wearable devices, and especially the ones dedicated to the COVID-19 diagnostics. And the sensors applications are directed towards magnetic field sensors and industrial applications. So let's dig in to find each and every theme covered by how many topics and whether they are in the scope of analog or digital electronics. I'm going to present first our first project theme, which is neuromorphic computing hardware. I'm offering two projects in this scope. The first one is the design and implementation of mixed signal neural networks, and this is number one, and the second one is designated by number two. Both projects are going to work together to form a small group. In this project, we're going to do the following. At the beginning, we're going to study the fundamentals of neuromorphic computing. Then we're going to move to comparative study between different circuit realizations of neural networks. These two topics are focused on mixed signal architectures, which means that we're going to use analog and digital circuit knowledge to implement this project, and the tools needed are Cadence and MATLAB or Python. Cadence will be used for the circuit simulation, MATLAB or Python will be used for the machine learning part. If we would complete this project successfully, it's a circuit level project, and going on to the layout and finalizing the layout to the end is a plus in these two projects. Now, this project is co-supervised by my colleague from Networks Department, Dr. Maggie Mashali, and she's going to be responsible for the part of neuromorphic computing. And these two topics will be also co-supervised by engineer Muhammad Al-Haddad, and he's doing his PhD in this topic, inshallah. So he's going to help us and be a co-supervisor on the project between which makes a hierarchy between myself and Dr. Megan, Engineer Haddad, and the two projects student working with us on this theme. Again, if you would choose this project, expect to use Cadence and MATLAB or Python, or to learn to improve your skills in them in order to achieve the required tasks. In the same theme of neuromorphic computing hardware, we're offering also two more projects, number 3 and 4, under the title of Digital Design of Artificial Neural Networks 1 and 2. However, these projects are completely focused on digital implementation of neural networks. It's not going to focus on analog implementations. So again, we will study the fundamentals of neuromorphic computing. We do a comparative study between different digital circuit implementations of ANN. And we will focus, as I said, on digital circuits architectures. Therefore, the tools that we're going to use will be Vivado. Also, we will use MATLAB or Python in order to do the machine learning part. And a plus for us will be the verifications on FPGAs. If the student were able to implement this up to the FPGA level, of course, it's going to be a plus. Again, the project is also co-supervised by my colleague Dr. Maggie Mashali, and the research assistant helping us out in this project is engineer Sandy Atif. The second project theme in the spring round is the IC design automation, and in this field we're going to have three projects. The first one is classifying analog and digital circuits with machine learning techniques. Here we are going to mix our knowledge with the circuit level, layout level, and we will learn about how to employ machine learning techniques as well to efficiently do the place and route on the integrated circuit. So at the beginning, we're going to study the fundamentals of machine learning as well, and we will explore placing and routing on integrated circuits and layout. Then we're going to build a model, a machine learning model, to classify the analog and digital circuits. The third step will be testing and training and testing the machine learning model. And in order to implement this project, the tools needed will be Cadence also and Python. It's a plus if we were able to apply this model in complex ICs and compare it with the state of the art. Again, this project is also co-supervised by my colleague Dr. Maggie Mashali, and we have our engineers, engineer Sandy Atif and engineer Sharif Abdin. They are going also to assist the bachelor student in this project. It's a very hot topic now, the IC design, automation, and the machine learning. So I guess it's going to be very knowledgeable in case someone of you chose it. It's going to open up a new doors for him or her. As I mentioned earlier, that in the theme of IC design automation, we will have 3 projects: the classification of analog and digital circuits, and the second one is going to be a comparative study of lay-aware sizing design techniques for analog integrated circuits. We all know from our study in the courses in the 7th semester how we would get different results if we migrated from the sizing up to the layout and the effect of the parasitics on the circuit specs. So we're going to study how to employ multiple techniques to make a layout aware sizing technique for analog integrated circuits. This project is focused on analog electronics, it's not a digital one. So we'll study again the fundamentals of machine learning, transistor sizing, and layout techniques. We will build a model to make the layout aware sizing of basic analog circuits, training and testing of the machine learning model, applying the concept on multiple circuits. And again, the tools will be Cadence and Python. This project is also co-supervised by Dr. Maggie, myself. I am the main supervisor, of course, and engineer Sandy Atif, and this is part of engineer Sharif Abdin master's topic, inshallah. Now coming to the last topic in the theme of IC design automation, the last one is going to be focused on analog layout. We will employ machine learning for analog IC layout design automation. This project is focused on layout, but be careful that this is just focusing on layout, not digital layout. So you have to study some more theoretical background on analog layout design techniques. We will also start by studying the fundamentals of machine learning, analog layout design. We will build a machine learning model for analog layout design optimization. We will focus on a basic analog circuit, and we will test and train the machine learning model. We will apply the concept on multiple circuits. And finally, we will use the tools of Cadence and Python as well. Again, a comparison with other techniques that use different methods for the design automation will be a plus. And again, this project is part of engineer Sharif Abdin master's thesis. Engineer Sandy is also with us, and the project is co-supervised by Dr. Maggie Mashali. Moving on to the third theme in the bachelor projects for this round, I'm going to start a new line of research in biomedical applications. This project is I'm mainly offering 2 projects in the biomedical applications field. The first one is the study of energy harvesting techniques for smart biomedical devices under the umbrella of Internet of Wearable Medical Things. The focus of this project is to design a power management system for powering up a wearable biomedical device, printed circuit board that could measure the vitals of the patient. So at the beginning of the project, we will study the fundamentals of energy harvesting techniques for biomedical sensors. We will design a signal conditioning circuit for energy harvesting. It's a plus, of course, if we were able to design and implement a flexible printed circuit board for the biomedical applications. Therefore, we're going to focus on different tools this time. We will use ADS for the circuit simulation. We will use also Protus or Altium for the printed circuit board. At the end of the project, we will aim to have a hardware prototype that is functioning, so we need to have it tested and validated. This project is co-supervised by my colleagues, Associate Professor Dr. Mohammed Abdel Ghani, and with my colleague Dr. Maggie Masheli. The second project in the field of biomedical applications is going to be Internet of Wearable Medical Things for COVID-19 diagnostics. Here we are going to focus on sensor study of which biomedical sensor that could be used to measure the health vital signs of patients of COVID-19. So the difference between project 9 and 8, here I'm going to focus on the sensors in 9 and 8. 9 is going to focus on the sensors. However, 8 is going to focus on the power management of the board. So we'll study the fundamentals of biomedical sensor signal conditioning. We will design a customized signal conditioning circuit for human vitals monitoring. And the third thing is that we're going to design and implement a flexible printed circuit board for the biomedical applications. Here the focus will be more on Protus and Altium. We may use ADS, but I guess here we're going to focus more on the printed circuit board simulation and verification. We will go, of course, up to from the circuit level, schematic board level, up to fabrication. So we will need by the end of the project a tested and validated hardware prototype. And again, the project is under the co-supervision of my colleagues, Dr. Mohammed Abdel Ghani and Dr. Maggie Masheli. The last project theme that I'm going to work on, inshallah, in spring 2022 is sensors applications, and I'm going to focus on industrial applications. And one of the main challenges in industry is measurement of the current without interrupting the circuit. So the focus on the project will be non-invasive current monitoring system using 3-axis magnetic field detection. So the focus will be on magnetic field integrated circuit usage in current monitoring systems. The objective is to be able to measure the current, position, and magnitude without intercepting the circuit flow. So at the beginning of the project, we will study the fundamentals of magnetic field sensors and their signal conditioning circuit. We will do measurement using these sensors to variable position and magnitude currents. So we have already a fabricated PCB, and we're going to employ the measurements and theoretical background equations, theoretical mathematical formulations to estimate the location and the magnitude of the current, and we will compare the theoretical and the measurement results for verification. In this project, there is some software tools like Protus and Altium and MATLAB, and however, this project you will go to the lab and do some measurement in the physics lab. So be ready if you choose this project to go to the lab and do the measurements by yourself. And of course, at the end of the project, we expect to have a hardware prototype that it's working, and we validate the theoretical equations. Here are at this end of the slide, I came to the end of the all my projects offered for electronics major. I hope you have a nice and good mid-year recess vacation, and think carefully about choosing your project. And I would like also to highlight that at the end of the project, we might continue in the summer for the internship, so please pick something that you are interested in order to be able to complete working on it in the summer vacation. See you soon, and good luck in choosing your bachelor thesis topic. Bye bye.